Okay, page 16. So we have two big ideas for today. One of them is how we can use quadratic functions in problems that have a context. So far, our big focus for this unit has been, here's a quadratic equation, solve it. Today, we're going to start to take a look at quadratic equations as ways to model or describe real world behavior. So that's the first thing we're going to look at today. And then the second thing we're going to look at today is one more option that we have for solving quadratic equations. Okay. So on page 16, we are going to start by looking at an application of a quadratic equation. So the left field wall in Fenway Park is called the Green Monster. It's a very big wall. It's 310 feet from home plate, and it is 37 feet tall. We're going to look at three different hitters hitting the ball and trying to hit the ball over the Green Monster. Okay, we're going to look at three different people hitting a baseball and trying to get it over that wall. So what we've got here, right here, is our wall. It is 310 feet from home plate. So I'm going to label this x-axis as my distance from home. Distance from home plate. And then we know that the wall is 37 feet tall. So that's what I see here, just under 40 feet. So my y-axis represents my height. Right now, the height of our wall. In just a second, the height of our baseballs. And then what we have are three different hitters. So these equations are all in vertex form. Notice they all have a negative lead coefficient. That should make sense. We're talking about hitting a baseball. So it's going to go up and then come down. Okay. So negative lead coefficient means my parabola is going to open down. Again, that should make sense for the context of our problem. And then every equation is a little bit different because everybody's going to hit a little differently. Maybe with some different force. Maybe you're hitting a different type of pitch. Maybe you make contact with the ball in a little bit different spot, or when the ball is maybe spinning a little bit differently than the person before you. So we've got vertex form equations. They all are going to generally look like this, but I've got some details that are different in each of these equations. What we're going to look at for each of these equations, remember these all describe somebody's hit. We're going to look at whether any of these made it over the wall. Okay, that's our question for today. Did any of these make it over the wall? If the ball makes it over the wall, it's a guaranteed home run. So that's what we're looking for. So we're going to start with our first hit. Okay, this is in vertex form. I know that my vertex would be 49, 195. I want to know what's the maximum height that my ball achieves. So height, remember, was on our y-axis. So that's going to be the y part of our vertex. The maximum height for this ball would be 195 feet. Okay, that's going to be, remember my vertex, that's going to be the top of the path that the ball travels. When it hits that peak height, it's going to be 49 feet from home plate. And then some other information I want to know about each of these hits. What's the height when I make contact with the bat? I'm just going to add with bat here. So what's the height when I hit the ball? Okay, how high off the ground is the ball when I hit it? That's going to be our y-intercept. And then I want to know what's the landing distance. How far away is the ball from home plate when it lands? Landing distance, okay? So that's going to be our right side x-intercept. Our right side x-intercept. And then we're going to use these pieces of information to decide if we've got a guaranteed home run or not. Does the ball make it over the wall? So we know the maximum height and the distance here because we had vertex form. So we know the vertex of this parabola. But we want to know the y-intercept, and we want to know that right x-intercept. When does the ball land? So to answer those questions, we're going to go to our graphing calculator. I'm going to pull that up here. I'm going to go to a graph page. And then I'm going to type in that function at the top of the column. So I'm just typing this in as it appears on my paper. There's my function as it appears on my paper. I'm going to hit enter. And notice that this doesn't look like a parabola, right? That's because I'm not getting a full picture. Remember, the vertex for this thing is at 49, 195. That's going to be way up off the part of the graph that I can see. So I'm going to adjust this so I get a little bit better picture. I'm going to hit the menu key and go to Window Zoom. And I'm going to choose Zoom Fit. I like Zoom Fit because it scales your graph in addition to zooming it a little bit. A lot of times it gives us a pretty good picture, sometimes not always the greatest picture. So for this particular graph, I still can't see that right x-intercept, so I need to zoom out a little bit more. So I'm going to go to Menu, Zoom Out, and I'm going to zoom out until I can see that other, there we go, that other x-intercept. Okay. And then I'm going to just move that function out of the way. And there were two pieces of information I wanted from the graph: the y-intercept and that right side x-intercept. To find the y-intercept, I'm going to bring up the table. So I'm going to hit that blue control button and then T to bring up my table. Remember, the y-intercept happens when x is 0. So in my table, I'm just going to arrow up to when x is 0, and there's my y-intercept. So my y-intercept is 2.92. So when I hit the ball, it's about 3 feet off the ground. And then I'm going to put the table away. So Control T again. And I want to find the x-intercept over here. So I'm going to hit Menu. And then I'm going to go down to Analyze Graph. And I want to find the 0. Okay, the 0 is the x-intercept. So I get this dashed line. Remember, I'm not trying to land the line right on the x-intercept. I want to click on either side of it. I'm going to click on this side of it, and then I'm going to click on the other side of it, and the calculator will find it for me. I don't have to try to land on it. Okay, so this tells me that my ball is going to hit the ground at 98.4 feet. I'm going to put my calculator away. Did you guys adjust your Zoom? Okay, I'll take a look at your calculators in just a second. Okay, so I'm going to put this away. And now I've got some key information for this hit. I'm going to go ahead and plot it on my coordinate plane up here that has the wall on it. So I know the vertex at 49, 195. So there's 50s right there, and 195 would be here-ish. So there would be my vertex. I know my y-intercept is right about 3, so it's going to be pretty low. And then I land at 98 feet. So there's 80, 90, 100, so right about there. So those are a couple of points that sort of describe my trajectory here. And then as I kind of sketch this in, this is the path that my ball takes. I hit it really high up in the air, but it doesn't go very far. This ball is going to make it over the wall. Here's the wall. No, we're going to hit the ground well before, right? So home run, no. I can't guarantee that this would be a home run. Now we're going to do the same thing with 2 other hits. So for my second equation, this describes my second hit. My vertex this time is 182, 10. The maximum height my ball reaches would be 10. Remember, our y coordinate gives us the height. It reaches that maximum height 182 feet from home plate. And now I want to find the y-intercept, the height when we make contact, and then the landing distance. When does it come back to the ground? Okay. So I'm going to go back to my calculator. Those of you that had an issue graphing that first function, I want you to hit the dock button. Dock button. And I want you to, insert a page. So dock, insert page. Okay. Make it a graph page, and then you're going to do exactly the same thing that we just did. Okay. I'm going to go ahead and just edit the function that I have here. If you want to make a completely new page, that's fine. If you want to make a completely new document, that's fine. I'm just going to edit the function that I have here. So I'm going to change that y coordinate to 10. I'm going to change that x coordinate to 182. And I'm going to change this to 0.0002. So now this is that second equation. I'm going to hit enter and my graph adjusts. Notice it looks really flat this time. That's okay. Okay, I'll take a look in just a second. Okay, now this graph that I have here is adjusted to best fit the last function. I want it to best fit this function. So I'm going to hit menu, zoom, fit, and then I'm going to zoom out a little bit. Oh. Okay, and then I changed this a little bit. I clicked on something I shouldn't have. So we are going to put this back. There we go. Okay, so I'm going to find my y-intercept, Control T to bring up our table, and then arrow up to when x is 0, y is 3.38 if I round to 2 decimal places. And then I'm going to put my table away with Control T. And then I'm going to find this x-intercept. So menu, analyze graph, 0. So my landing distance is 406. Now I want you, back in our notes, to plot the vertex, the y-intercept, and that landing distance. You guys that had calculator issues, I'm going to come to. Okay. Okay, so if I look at the graph for this thing, my vertex is at 182, 10. So 180 would be about here, and 10 would be about a quarter of the way up. So there's my vertex. My y-intercept is at about 3, so it's pretty close to the other y-intercept. And then my landing distance should be 406. So right about there. This is kind of hard to sketch because it's such a wide and flat parabola. There we go. There's that second hit. So it only makes it at most 10 feet off the ground. Question? How'd I do what? So the 10 and the 182 came from the vertex. And then on the calculator, is that your question? So we had vertex form. So I got my vertex from there. And then the y-intercept and that right x-intercept I got from my calculator. So based on the information that we have here, our ball should hit the ground at 406 feet. So over here. Is it going to make it there? No. What's it going to do? It's going to hit the wall, right? Is it going to make it over the wall? Not a chance. The highest our ball gets is 10 feet off the ground. Our wall is 37 feet tall. So this is not going to make it over the wall. It will make it to the wall, but it's not going to make it over. We've got one more. Okay, we've got one more hit we're going to look at. So I'm going to go back to my actually, before we go back to our calculator, let's pick out the vertex here. That would be 173, 123. So my maximum height, remember height is our y coordinate. Our maximum height is 123 feet. We hit that maximum height 173 feet away from home plate. I want to know what's my y-intercept? How high off the ground is the ball when I hit it? And then what's our landing distance? What's that right x-intercept? So now I'm going to go back to my calculator. And again, I'm going to just edit the function that I have here. So this will be 123 at the end. And 173 there inside parentheses. And negative 0.004 for our lead coefficient. Okay. And here we see a very tall parabola. I can't see the vertex, it's up here somewhere, but I can see both sides of it. And the nice thing here is that my x-intercept has sort of carried along with. So that right x-intercept, that landing distance, is 348. So I'm going to drop that down. And then I want to find my y-intercept. So the blue control button, and then T, arrow up to when x is 0, and there's my y-intercept, 3.28. And then I'm going to put this away. So here's all that key information. I'm going to plot the information that I have on my graph. So I have my vertex that comes from these pieces. So 173, 123. So there's 160, 170, 173 is in here somewhere. And then 120 something. There-ish. My y-intercept is 3.28. So again, that's kind of right over where the other ones are. And then our landing distance is 348. So 220, 330, 340, 350. And then I'm just going to kind of sketch in my parabola. Now, this is not as clear cut as the other problems that we looked at. Based on my sketch, it's hard to tell if the ball is going to make it over the wall or not. So I'm going to go back to my calculator, okay? What I want to know, and I'm going to use my calculator to figure this out, is how high is the ball at this point, right? I want to know for the x coordinate here, what's the y? That's what I want to know. If it's more than 37, we make it over the wall. If it's less than 37, we're going to hit the wall. The x coordinate here I know, because I know that the wall is 310 feet from home plate. So I want to know what's the coordinate when x is 310. One action is to take 310 and plug it in for x in my function. But since we've already graphed this, I'm going to use my graph to answer that question. So I'm going to go back to my calculator. And I could scroll in my table until I get to when x is 310, but that will take me a minute. So I'm going to put the table away. And I'm going to use a graph trace. I'm going to hit the menu key, go down to trace, and select graph trace. So this lets me kind of inch along my graph and find different points. So if you look down here, you've got the coordinate for wherever my little bullseye is. Notice that it kind of hops around, okay? It jumps. If I want to find an exact location, my best bet is actually just to type in the x value that I want using my number keys over here. So I want to know what's the y when x is 310. So I'm going to type 310 and hit enter. And it jumps to that point. So here are my coordinates, 310, comma, 47.9. So I'm going to jot that down and I'm going to put my calculator away. So the height of my ball right at the wall is 47.9. Does it make it over? Yes, because the wall is 37 feet tall, so we're about 10 feet above, almost 11 feet above. So this last one is a guaranteed home run. So here's what we've done. We had a problem with the context to it. I didn't just give you a function and say solve this, but I gave you functions that described something, in this case, motion of a baseball. And I gave you a context. I said, does the ball make it over the wall? Make it over the green monster? We looked at the vertex of these functions. We looked at the y-intercept. We looked at an x-intercept. And we used these key features to be able to make some determinations. For our first two functions, the key features were enough to decide that no, we're not going to make it over the wall. For our last function, those key features that we looked at weren't enough to make that decision. So we looked at another feature of our graph. Now, we haven't ever looked at what's the coordinate when x is 310 for any other function, because that's not what we would call a key feature that we care about for every graph. But it was important for this graph. So we found an important feature for this particular context, and then use that information from our function to answer a question, to make a decision. Okay. We're going to see some more problems like this tomorrow, and we'll continue to practice this later this week. For the rest of class today, I want to shift gears a little bit and talk about our last option to be able to solve quadratic equations. If you take a look at the equations that we use today, none of them are very nice. They're in vertex form, which was convenient based on the information that we wanted. And to type them in our calculators, they weren't bad to graph. But if I were to try to solve one of these quadratic equations, and if I turn over to the next page, I have one of those functions written a little more clearly for me. If I were to try to solve this, I'd have to start by moving the 195 to the other side. That's not so bad. But then I've got to divide by negative 0.08. That's not so nice. And then I would have to take the square root of whatever number that is. And then I would have to move the 49. And moving the 49 is not a big deal. But dividing by this decimal and then taking a square root of whatever I get, that's probably going to trip us up a little bit. Okay. So what we're going to look at is a way that we can approach functions that aren't going to be very nice to solve using any of the methods we've talked about so far. The square root would probably be our best option here, but it's still not going to be a nice option. if I changed it to standard form, this is not something I'm going to be able to factor, and it's not something that would be nice to complete the square on, okay? So what we want is another option. What's something else? So the something else is what we call quadratic formula. To use quadratic formula, I have to have my function in standard form. That means the x squared term, then the x term, then the constant term, everything on the same side set equal to 0. I have to have standard form. Just like if we're going to factor, we have to have standard form. If we want to use quadratic formula, we have to have standard form. Once I have standard form, we're going to use my coefficient and my constant term, and we're going to plug them into the formula I'm going to give you right now. So our solutions, if I use quadratic formula, would come from this. So I take whatever my b value is, and I change the sign on it. And then plus or minus the square root, and all of this is under the square root of that b term squared, minus 4 times that a value times our c value. And then all of this is divided by 2 times whatever our a value is. This is quadratic formula. So let's take a look at this in action with one of our problems. So here's standard form for another of those problems that we just looked at, another of those equations from our home run example. So here's A, here's B, and here's C. I'm going to take these numbers and plug them into quadratic formula. Okay, so here's what this looks like. Change the sign on B. So since my B value is positive, I'm going to make it negative. Plus or minus. Then I'm going to take that B term and square it. Minus 4 times our A value times our C value. Again, all of this is under the square root. And then everything is divided by 2 times our A value. We're going to use our calculators to help us simplify these, but I can't type this exactly as it's written into my calculator. Why not? Where will I have a problem if I try to type this into my calculator? What have I written here that I cannot type in a calculator? Yeah, the plus or minus. That's going to be a problem. Here's how we get around it. We type this in with just the plus sign, and then I type it in again with just the minus sign. We're going to get 2 different solutions. It's just like when we had solving by square roots, we got something like this. So we said split it up. So we could get our 2 solutions. We're going to do the same thing here. So I'm going to pull up my calculator and I'm going to type this in with just the plus sign. So I'm going to just bring up my sketch pad here. And I'm going to hit Control Divide to start off so that I get that fraction right out of the gate. And then negative 0.0728 plus, there's my square root, 0.0728 squared minus 4 times negative 0.0002 times 3.3752, and then arrow down to the bottom part, and this is 2 times negative 0.0002. There's my function, exactly as I wrote it on my paper, but with only the plus sign. Hit enter. There's my first solution. So I get x equals negative 41.61. And now I need to do the same thing with just the minus sign. The good news is you don't have to type it in from scratch again. Here's what I want you to do. Arrow up until you've highlighted your quadratic formula. Hit enter. And then arrow back in your quadratic formula until you get to the plus sign. Change it to a minus sign. Okay, you don't have to type the whole thing in from scratch again. Then hit enter and you've got your other solution. Questions for me? Yes. I want you now to try this with B. So here's your A, here's your B, and here's your C. This would be negative 1.384 plus or minus, inside the square root, 1.384 squared minus 4 times our A value, which is negative 0.004 times C, which is 3.284. And then all of this is over 2 times our A value, negative 0.004. If you are in the 2 rows closest to me, I want you to type this in your calculator with the plus sign. If you are in the rows farthest from me, the 3 rows farthest from me, I want you to type this in your calculator with the minus sign. Okay, so we're going to divide and conquer here. The 2 rows closest to me, so Drew's row this way, you're typing this in your calculator with the plus sign. Everyone else, you're typing this in your calculator with the minus sign. If you type this in your calculator with the plus sign, this should be the solution you got. If it's not, let me know so we can check what you punched in. If you type this in your calculator with the minus sign, this should be the solution you got. If it's not, let me know so we can check your entry. We need to check something. Okay. Okay, that's where we're going to stop for today. No new homework. Tomorrow, we're going to do some more practice with this. Okay.